We're starting our next topic. So that is unit number 3.4.8. It covers maintenance of PV system. So the maintenance that refers to fixing any sort of mechanical, plumbing or electrical work so that the component or equipment or system does not go out of order or it doesn't breaks. Means everything should be proper, and to make it proper, the task which we do that comes under maintenance. So maintenance, basically the two type of maintenance which we are classifying as unscheduled maintenance and scheduled maintenance. So unscheduled maintenance that is performed when there is a sudden fault or damage to the system or its components. So unscheduled maintenance involves repair or replacement of component of the system. Means something, uh, some fault or something unusual, unwanted that has occurred. Now we are checking that what went wrong in our system after something has gone wrong. So that is unscheduled. The scheduled maintenance that is already pre-planned. So we have scheduled that at a duration. After, let us say that after this much time or this much months, this much days, after that time is over, we check the components in the PV system. So that comes under scheduled maintenance. So it is performed as a routine checkup to maintain the components of a system so that the system and its components are in proper working condition. Okay, so it is done periodically, just as I said that after some predefined time interval, we are performing the this scheduled maintenance. The PV system and its component, they require less maintenance as compared to other power systems. So although a few periodic maintenance tasks should be performed on the PV components, means we should check at regular intervals whether all the components they are working properly. Okay, so that is a scheduled maintenance. So on comparing with other power systems, the maintenance is less in our PV system. Okay, then while performing maintenance for PV components, it is must to refer the component specification sheet or the catalog provided by the supplier. Okay, so the whatever catalog that is having all of the detailed specifications of the products. So the installer, our PV installer, that should be properly familiar with the component. What are the specifications of the component in our PV system? So in order to make it up to date in his knowledge, he should go through the company catalog. Okay, then the installer should be aware of the necessary precautions to be taken while maintaining the components. So what are the precautions which we need to take? So all of these details our installer should be aware of. So the associated components of a PV system, such as batteries, charge controller, they need to be maintained once in a fortnight. Okay, so yeah, in the fortnight, we should clean the panel so that the dust, leaves, bird dropping, etc., these are removed from the surface of the panel. In a fortnight, approximately 15 days, clean the solar panel, the surface of the solar panel especially. So only water is used and no other cleaning agent. With solar panel, secondary battery maintenance becomes minimum. But still, periodical maintenance of battery should be carried out in the usual manner as per the maintenance manual. So whatever is being specified in the manual, in that duration, we should check the respective quantities, parameters of the battery. like a scheduled maintenance. Now next we come to troubleshooting of PV components. So a variety of problem solving and troubleshooting techniques means there is something unusual and we should detect it. We should correct it in our solar system, a PV system. So they're applied for repair of failed system, process or product. Some preventive action, some corrective action that is needed. So that is troubleshooting. It is a reasonable methodical search for the cause of a problem, issues for the purpose of a resolution, and so that the module process system can be made functional again. If something went wrong, our system is not working properly. So in the corrective measure, the action to correct that, that is a troubleshooting. That is reasonable methodical search. Okay, means something, some method that is specified, we have to go as per that and search for issues and make our system function in a proper specified manner. The proper working of the PV system would be possible if during the initial phase of installation, a high quality and proper designed system is installed. So under the section of installation, we have discussed different precautions, methods for installation. So that highly depends or it highly affects the normal working of the system. If something, if some precautions are not taken at the time of installation, okay, in that case, there is a most high probability that the system will be having issues. Some type of faults would be there. Functioning would not be as expected. So if regular maintenance of the system and its components that is done, then we can assure that our system will work properly as expected, as specified. So some of the probable reasons of faults in a PV system. Okay, here some of the reasons are there. Cloudy weather, clouds are there, sunlight that is reduced. So shading of PV modules, shading due to some other objects, nearby objects. Then dust settling on the PV modules. That's why we have to clean it. Blowing of fuses. Okay, the fuse blows out, then we won't be getting any output from the panel. Then empty batteries, that degrades the performance. Battery's life also degrades, system performance also degrades with empty batteries. So we have to regularly check the electrolyte level, the water level in the battery. Next, stripping of circuit breakers. Circuit breakers, they are isolating some section of the system, of the power system. So if the circuit breaker is stripped, then it means something unusual, some fault has occurred and we are not getting an output from the system. Then bad connection. So that is why our installation process is so important, that we have to follow all the specified procedure, all the precautions should be taken so that bad connection is not there. Otherwise, there will be a fault in the system. Now, how to troubleshoot the fault which has occurred in our system? So the basic troubleshooting starts with visual inspection of different components. Let's properly check, see each component. So the installer, the PV technician should be able to check the PV array for partial shading or dirt. Then check all the fuses and the circuit breaker. Check the junction boxes, the distribution boxes and wiring for loose connections and for corrosion. Then check the PV modules and batteries for proper series parallel combination, because output voltage current that totally depends on the series parallel configuration. Okay, that's why in the previous section in the precautions we studied about the corrosion, the selected metal used for installing the solar system should not be affected by corrosion. Then the installer should check system wiring using multimeter for proper polarity and continuity. Continuity means the wires which are connecting, they are not broken. If a wire is broken, then what, the output will not be available to reach the next component. Output from one component that won't be able to reach the next component because the wire is broken. So continuity should be proper. Polarity, like the positive and negative terminals of one device, they are not interchanged. Like positive terminal of one component is connected to negative terminal of another component. Polarities are changed. There will be a fault. And installer should check the meters installed in the system for proper voltage and current readings. The measurement, the monitoring, that should be accurate. The solar PV source is a reliable source of electrical energy, but there could be some cases, some instance when the power is not able to drive the connected equipment, means we are not getting the power. So first, how to detect it, how to correct it. So that is the troubleshooting. So we start with battery. So the panel installer must check the voltage of the battery bank. So if the battery bank is correct, okay, we started with the battery, but our batteries are correct. They are working properly. So what could be the reason for the fault? So reason could be either the inverter is tripped, or the switch or the load MCB is tripped, or the load fuse is blown off. So these are the common causes. Then we should check for these things, for the inverter, for the load MCB, for the load fuse. Okay, if none of them, this fault is observed, then analyze the exact gravity of electrolyte present in the battery secondary cells. Exact gravity, basically that is a measure ratio of the weight of the battery to the water. So there may be two cases, like specific gravity is above the level as specified in the maintenance manual. So that is specified. What is the specific gravity of that electrolyte? That is given in the battery's manual. In the maintenance section, it is given. So battery is in order, and the problem would be either with the charge controller or the load. Okay, the specific battery is above the level, then either the charge controller or the load, they are having some issue. So first disconnect the load from the charge controller and connect it directly to the battery. If the equipment operates, then it means the charge controller is defected, because we have removed the charge controller, directly connected the load with the battery, and it is working. It means that the charge controller was faulty. Second, disconnect the charge controller and check as per troubleshooting instruction given in the manual supplied with it. Okay, still the problem is not solved, then we need to inform the manufacturer or the supplier. The specific gravity of the electrode is below the specified level and red LED is glowing. If it was above the level, then charge controller or the load was having some issue. We need to check the charge controller. Okay, now next thing, if it is below specific gravity of the electrolyte, that is below the specified level. In that case, load may be drawing more current from the battery than required. So if that happens, then battery is bound to get discharged. Okay, the solar panels are working properly, but still the battery will discharge because the load is drawing more current. So the battery is getting discharged, so load will be tripped very frequently because battery is discharged now. No charge. Okay, now to avoid this situation, so we need to check the load equipments and replace any defective component. Due to which defective component, the larger current is being drawn by the battery. The SPV panel, solar panel, may not be producing required power for which the power source has been designed. That means power produced by the panel that is less than specified. Then check for any loose connection, any wire if it is broken in the connections of the solar photovoltaic module or the panel. Could be some type of loose connection or breakage of wire. That's why we are getting lesser amount of power. If we are not getting it, then maybe the panel surface that is not clean. Okay, so even when there is a bright sunshine, to measure the voltage and current of each module after disconnecting the wire. So different modules, they are connected in series parallel configuration. So check every module. If any one single module is giving a less voltage or less current, even in a good amount of sunlight is available, then we need to inform the manufacturer, the supplier. Okay, then we should specify the module serial number and the measurement taken for necessary investigation. Then we need to investigate why a lesser number of electricity is being produced by the solar panel system. Then failure of blocking diode. Again, in that case, the voltage across the terminal will be zero. The terminals of the diode, it is zero. It should be 0.7 volt. And the charging current will be flowing through it. So when it falls in open circuit mode, the current will not flow through the diode. So we need to check the diode also, as per the standard method of checking diode by removing the circuit. So there could be fault with the blocking diode as well. We need to check it as also. The next section 3.4.10 that covers troubleshooting faults in a PV system. So some of the faults, their cause and the corrective measure or the action which we have to take, that installer has to take. So they are specified here in this table. So first fault which we are facing, that is no output. We are not getting any output. So cause could be break of conductor, means a wire that is broken. So we're not getting any output. In that case, replace the cable. Okay. Corrosion of cable. There could be corrosion. Or there could be improper or loose connection. Maybe like the positive wire is connected to the negative terminal. So in that case, we need to check the polarity of the connecting wires. Also, we should check the corrosion on the wires. So it is not due to corrosion. We should make it assured. Okay, next cause for no output, that is defective connector. The connector that is defective, so it is not making a proper circuit. So in that case, replace the connector. Then loose connection, corrosion of connector, improper fixing of the connector. In that case, adjust the connector as per the specified instructions. So another reason for no output could be damaged junction box. So we need to send the junction box for the service to the manufacturer, to the factory. Next reason is a failure of charge controller. Just a minute. So failure of charge controller. In that case, replace the charge controller. Then there could be some internal problem. We cannot check there inside the panel. We cannot check what is the fault inside the panel. So in that case, we need to send the panel for the factory. So it is in warranty period, so it will be exchanged. Okay, now next fault could be like the output voltage is okay. Means the specified voltage we are getting, but we are not getting output current. So the reason could be damage of a cell or interconnection problem. So that also needs to be corrected by the factory, the manufacturer. So next error could be shading of the PV module. In case some type of shading is coming on the PV module, in that case we need to remove the shade or change the location of the module so that maximum sunlight should fall on the surface of the module. The next error could be dirt on the panels. That is also blocking the light. Okay, that is, we need to clean the module panel. Okay, so this fault is this reason, this causes no charging indication on the charge controller. Okay, means charge controller that is not giving any indication of charging. So this type of error we are facing. So that could be due to shading of PV module, dirt on the panels. So either remove the shades, rearrange the modules in the proper position, or clean the modules. Okay, another reason could be the module is broken. So we need to replace it. Then electronic failure of charge controller. We need to replace the charge controller. Next reason could be break of conductor. So a wire that is broken, so need to replace it. Corrosion, improper connection. In that case, we need to check whether the corrosion is there or not. Make proper connections, check the polarity. If it is wrong, then we need to correct it. So the next fault or the symptom, that is output voltage for less duration. So that could be due to shading. So same action can be taken, remove the shades or rearrange the position of the panels. Then dirt on the panel, then we need to clean it. Improper installation. So we need to reinstall the panel in a proper position so as to get maximum sunlight. Okay, then module if it is broken, charge controller is not working, so we need to replace both of them. So whichever is not working. Then conductor broken, the same thing which we studied in the previous issue. So if the battery is not sufficiently charged, then we need to charge the battery to full capacity, full requirement. Okay, acid leak problem could be there. Terminal of the battery could be broken. So issues with the battery could also be there, so that we are not getting sufficient or output from the at the low terminal. Okay, next fault is no voltage across blocking diode. In that case, the diode is damaged. It has failed, so we need to replace it. And in case high voltage across blocking diode, then diode also failed. When we get a high voltage, when the diode is open circuited, it's a very high voltage. And in case if it is short circuited, then no voltage drop across the diode. Zero resistance, zero voltage drop. In both of these cases, if there is a fault with the diode, we need to replace the diode. Okay, so here this unit number 3.4 that ends.